Sunya this side. In this video, we are going to talk about I2C communication method. This is one of the communication method used by the sensor to transmit their data to microcontroller. So, I2C means inter-integrated circuit communication. This is one of the communication method used by the sensor to transmit the data to microcontroller. So, you might be seeing some sensor like which have a HCL and SDO pin or pins. So this SCL and SDL pin used in I2C communication method to communicate with the micro. So before going to I2C, we will consider an example. If we are going to know about the I2C or I2C, I am taking one example like microcontroller has Arduino and a device has a 7-segment display. So I want to send a data from microcontroller to device. I use digital signal pin which is connected to 7-segment display. So to transfer the data, one by one it is transfer the data by Arduino to device. So here we want 8 digital pins to transfer the 8-bit data, and it was connected to our device. It can be possible by using 8 digital pins. So to overcome this drawback, like it's require lots of pin to transfer the data, and we can connect more devices. So to work on this, there is a I2C or I2C. To work on the issue like that we see last slide, that I connected to Arduino in 7-segment display, that I need this 8 digital pins, 8 signals. So here we come to the I2C or I2C. So here we have SCL or SDA pins. To solve this problem, that's why I2C is designed. So we have to transfer the data or read-write communication. Only the two pin is required, that is SCL and SDA. By using this 2 pin, we can perform write operation. Here we can say that, here we can see both the register SL pin and SDA pin, which is pull up by the VCC, which is 5 volt, which it is depend voltage is depend on a particular microcontroller, which microcontroller you are using. It may be 5 volt, 3 volt, maybe it's depend on microcontroller. So here SCL and SDA, which is pull up by the voltage, so that's why it's always high, that is 1. Over here the first microcontroller is called as a master, and the device from which we have transfer the data, read or write or send the data, is called as slave. So over here the order to communicate, we require only 2 pins, that is SDA and SCL pin. SCL pin, which is pull up by the voltage source register, voltage with the registers. That VCC is depends upon particular microcontroller that we are used. So which can be 5 volt or it can be 3.3 volts. So that SCL or SDA pin will be always remain high initially, because as I told you that it is connected to the VCC. It's always it is a 1. And by using SCL and SDA pins, not only one device, in fact, can control multiple devices over here. And that multiple device can have multiple master and multiple slaves. Here, to differentiate the devices address is play an important role. Every devices have their own unique address, which we have used in order to send or receive the data. So as we see that in the 7-segment display and Arduino case, that only 7 digital pins are already connected to the that 7-segment display. So there is no digital pins remain to connect another device. So here this IC2 or I2C had the play an important role. Just in 2 pins like SDA and SCL. By using these 2 pins, we can connect multiple devices at many devices. In fact, you can connect total 128 devices to such as to the same SCL and SDA pins. was the huge feature of IC2 I squares or I square C. Here we are having a master. So here we have a master as a microcontroller and a device device is the slave. So this master want to communicate master want to communicate between this slave. So this master wants that send the data to slave, that is just consider as a one data like 101010. How that data is going to send into VLSI communication? Let's see that. So first of all, what is the master want to do? It will send a start bit to our slave, that is a 0 bit. So whenever our master want to communicate with the slave, so he every time he will send a start bit. This the value of it is always the 0. Why 0? Because I already told you that SCL and SDA are connected to the voltage source that is pulled up by the register. It means its value is 1. So we want to communication here. So we are sending the data to start the communication, that is 0. So um, over here 0 is sent to the sent to a start bit. So after that our SCL pin and in that means SCL pin is serial clock which is get start. After that this will be start acting as a pulse. So this is the first process. After that, to which device want to communicate, which which master want to send the data, we have to know find that device. So I told you that in previously slide I told you there are multiple master and slave connected to the this two pin SCL and SDL. So they have a unique address, device address. So we have to find which device want to communicate. So the device address, at this time the device address play an important role. So for example, consider as one example for knowing the how it work IC2 or I2C. So I have considered a OLDC display device. This device address is the 3C. So and it binary convert into 1 0 So and in I2C communication method, we can have a device address of 7 bit. So we can connect 128 device in to the single master, because of maximum number of device is the 2 with the power 7 2 raised to power 7, that is 128. So we can connect 128 device to single master after um, to communicate the data communication between the master and slave. So after sending the start bit, we have to send the which device want to communicate. So like there are multiple devices connected to the. I told you that multiple devices connected. So we have to identify which device want to communicate right now. So there is the unique address which is denoted to every device. So we have to send that data also for the getting the known which data want to communicate. And here is one more thing is more important, that which is a very important, that is our STL serial clock. So this pin whenever this pin is high, at that time only it will send the data, and because of that all this data are synchronized and synchronize and align, and they do not get mixed.